workshop. Was there any concluding things we wanted to say in the workshop?
David, you're making the concluding comments, right?
Oh, I'm making the concluding comments.
Well, you're listed as the closing person.
Oh, okay.
Please tell us what's your.
I had one thought I did want to share. That was my experience. I thought it's too bad that Leslie is now gone. I believe he is, unless he came back. I was a little bit intimidated when he said I had to watch his video before I could come to his talk. And I sort of said, well, okay. But then since I'm an organizer and I had to pay attention to everything, I had to go do it. So I went and did it, and it got me to read all of the papers, which are very, they're all relatively short. So it turned out to be easy to read all of the papers. It didn't take that long. And I did that at the beginning of the week on Monday. And so I had this whole week to think about things. And I found that I was able to internalize a lot more of the things that people were saying and raised a lot of questions in my mind, which I found very useful. Anyway, so what my insight might be that maybe the next time we do a workshop, we ought to think about doing something along those lines of giving time for slow people like me to think about something a little bit on our own and then come back. And so my thought was, well, maybe the first day we have talks, and then the second day we have questions and answers.
That's good. A 2-day or 1.5 day.
And then Annie said, I tried to explain this to Annie briefly in writing it, and I didn't do a very good job. And so Annie interpreted it slightly different, thought I said something differently. And so she had an even better idea. Now, I'm afraid this probably isn't going to work in the virtual world of COVID, but maybe if we ever get back to the human world of actually going places and meeting up personally, we could try it. And her thought was that there'd be talks on the first day, and then the second day would be excursion, when we could all get together informally and talk about the things that we had read up, we had seen. And then the third day would come back and have have the questions and be able to come back to the.
We hope that the next year or the next 2-year LPOP will actually be in person again, right? Yeah. We can go to a cafe and over a beer.
There we go. Anyway, so
right? I really miss that.
Even if it's let's hope.
Anyway,
you can have it.
Think about that. You don't have to respond right now. You can think about it for a little while. And maybe in 2 days we can come back and talk about the.
Yeah. David, what you're describing is, I think, more succinctly, typically called breakout and reconvene to the plenary.
Sounds good.
So maybe I want to just thank all the speakers, and including I really wanted to say, actually, we have all these prestigious, famous, professors or researchers, and we had really one student here at the end that gave this talk, and every speaker and just gave a beautiful talk, and was very impressed. Is Daniel still here?
He had to leave, but yeah, he might still be here, but he had to leave.
Yeah. So thanks to all the speakers.
Yeah, he did very well, huh?
Yeah,
good master student. I would hire him.
Yes, thank you to everybody who participated. I found this a very fascinating, very productive, very interesting, or at least thought-provoking discussions, all of them. So anyway, thank you. I would like to thank everybody for joining and participating as actively as we all did. So good.
Are we going to leave this open now to continue this
Organizing it. I have to leave, but thank you guys for organizing it. Thanks a lot for the effort.
I'll see you.
Thank you.
I have to leave.
I'll see everyone. I'll see everyone at the bar later.
There we go.
And many thanks to David for moderating.
Yeah.
Many thanks
Thank you for
organizers
organizing and moderating, and I think this was quite interesting. I personally would like to keep talking about the frame stuff with, but Bob and
Yeah, I
Vladimir
actually have a
and
question
some of
for
the other
Bob too.
folks.
I mean, not question. I was really shocked at first when he just formally said no iteration, no recursion. And I, of course, as a programmer, I loved iteration and recursion, but I observed that some people have trouble with recursion and less with iteration, some are the other way. And but with somebody who thought so much about it and said it so clearly, I have to say, indeed, like Leslie's example, right? No recursion, no iteration. and by the way, there's a huge discussion on the side. I'm really slow at reading about SQL. You think about most people or most SQL used, right? That's the select statements. No recursion, no iteration.
But it's a join. It's logic. It's
Yeah, sure,
two
but that's what
predicates
works,
with
right? That's
arguments, right?
Bob wrote all these conditions. They're all joins.
Yeah, but a join is a typical Prolog thing, you know?
But it's
Two
not
predicates.
recursion or iteration.
But there
Fine.
are concurrent,
Forget recursion.
concurrent updates essential to SQL. They have a transaction. Concurrent updates. That ain't classical logic programming.
No, it
Concurrent
isn't.
updates.
It isn't. It's not only logic, but it is logic and something else.
Something else. That's right.
Transaction
Encapsulate-
is not logic, yeah? Yeah. It's
So,
doing.
yeah, I had a question specifically on the frame stuff.
Actually,
So,
okay, go
yeah.
ahead.
So Bob,
Bye, guys.
I'm not sure. I mean, there's an analogy between leaving frame fluent persistency inferences implicit and leaving negation as failure conclusions implicit. And there's not just an analogy. A lot of times you can implement the former via the latter. So I'm not sure. I mean, Bob, I agree with you that a lot of people didn't take frame problem seriously enough in terms of practicalities of scaling up. And I think one of the nice discoveries I personally made in some of my research over the last decade was that you could use restraint, namely this approach to using an undefined truth value and a more broad set of purposes to leave essentially kind of NAFy, kind of like NAF, but even more humble epistemically. Just go, okay, I don't even want to try to draw a conclusion about whether a fluent that's, say, 1 billion time steps out holds versus does not. And that enables a great knob for control when you scale up to be selective and judicious about where you want to actually put not only your computational effort, but even semantically what your expected set of conclusions are going to be that the computation then is expected to support. And so, I think between that and some of the stuff that Michael Gelfand and Vladimir also, has done a tremendous amount of fundamental work on treatment of the frame problem starting decades ago. I'm not sure what the current issues are in terms of what's known research-wise versus what's implemented in the practical systems. And so I'm kind of curious what your take on that is, Bob.
I'm not sure that I can say much more than I already said before. I am reminded of something that Vladimir once said to me when I suggested that negation in stable model semantics is best understood epistemically, which of course Gelfand, Michael, introduced to begin with. And he said that he thought there were, as I recall, Vladimir, correct me if I'm mistaken, he said that you could look at it in terms of classical negation as much as you could in terms of default epistemic negation. You said that you could view that, so a fluent is false at a particular point of time if it is not true. So even in classical logic, you can define negation being true if the positive atom that is negated is not.
You have to introduce modality. there to do that. That was Vladimir's approach, is my recollection. So
Yeah.
I think that that's pretty crucial. It still is epistemic in that sense, because you've got this essentially belief modal in there that you're applying the classical negation to.
Well, I mean, that's what I was arguing, and Vladimir didn't convince me at the time, but I have since been convinced in my own work on this language LPS. So in LPS, we like in relational databases, think of the state of the relational database as a model, and you want to know if something is true. If the fact is in the database, you say it's true. If the fact is not in the database, you say the fact is false. So so-called negation is failure is nothing other than the conventional way of defining truth for negative sentences in a model. You don't need an epistemic interpretation. This is what I understood Vladimir said to me several years ago, and something I rediscovered in my own work. I don't know how many years ago, 10 maybe.
Well, the way I see it is that the difference between classical negation as failure becomes essential in situations when we deal with incomplete information. If we understand that our database can tell us that some assertions are true, some assertions are false, and about some assertions it may be information may not be available, then it seems to me that the use of programs with two kinds of negations is a very elegant way of expressing this. But in many cases, when we take it for granted that that answers to all questions are available, if we don't have information fluent is true, then it is false, then there is no need to distinguish between these two kinds of negation. That's the way I see this.
I agree with you.
Right. So negation of failure was introduced in Planner in 1969 because we didn't have enough memory on the PDP-6. We didn't have enough memory to work on more than one goal at the same time. So we had to get that memory back very quickly. So we introduced the backtracking and the negation of failure. But I now think it was a mistake, right? But now that we have these many core systems, we can work on as many goals as we want to at the same time, right? And just because you haven't, you can no longer exhaustively go around, trying everything, right? And getting back the results from everybody. So it's just, at this point, it's just a mistake. Use real logical negation, which is what logicians should be using anyway.
Yeah, if you can.
There are too many negative facts to put them into a database. If you look at a relational database, if you have all the, say for a railway train schedule, so it only contains positive train connections. If you put in all the negative, you'd have an infinite number of negative sentences which are true. It's just
no, but you're not. SQL doesn't have negation. Classical databases, they just have tables. So what you represent is whether something's in a table or not, and that is decidable. So truth and false is not decidable, but whether or not something is in a given finite table is absolutely decidable.
Well, that's how NAF works, Carl.
That's how SQL works.
Yeah.
That's not how logic works. It's not logical negation, whether something's in a table.
It's not classical.
Negation is hard. Come on, you guys.
It is. And double negation is even better.
Well, it goes away.
Depends on whether you regard it.
Intuitionistic logic, it doesn't. No. If you got three of them, you go down to one, but that's it.
Depends on whether you regard a database as a model or as a theory. So Ray Reiter did a lot of work looking at the relationship between databases as theories, databases as models. If a database is a theory, then you're right. You have to do you have to write down the negative sentences that are all true. But if a database is a model, to know that something to know that a negative sentence is true, you simply need to know that the positive sentence, which is negated, is not true. So that actually, sounds like a negation is failure, but it's given to you by the model theoretic view of the database rather than the theoremhood view of the database.
In SQL, it's a finite table. It's either there or not.
Well, talk about logic. I mean, there's two sorts of logic. There's logic as a theory, and there's logic as a model, and they make there's a world of difference between them. You know, SQL can be viewed. The database of SQL can be viewed either as a model or as a theory, but it can't be viewed just as SQL. It's one or the other if you're looking at it from a logical point of view.
But it's an approximation to what exists in the real world. So you can't say if it's a model that it's correct. A database giving information about people will be a snapshot of what the true situation is in reality. So only in things like a bank account where the money in there, it's actually correct. You can consider it a model. But if it's giving information,
model in the sense of mathematics, model theoretic structure. So I'm not talking about modeling the world. I'm talking about
I understand
theoretic structure.
Sure, but if the database is it is the structure you're talking about, then it's a model, of course, and it is the structure. So a bank account typically is that because you have that money and it's there, it's yours. But databases that give information about people, like their names and addresses, that's usually not completely correct, because the person's name might have changed and the database is not updated.
But that's not,
But you never know what the balance is now. You only know what the balance used to be.
No, transactions are done when the balance changes. It's an immediate transaction.
Yeah, but once it gets back to my computer, I don't know what the balance is anymore. I know
But your computer is not the correct thing. It's the database at the bank that has the correct information, not your computer.
by the time it's told me, the balance could have changed.
Yeah, but what tells you is not the model. What's inside the database?
actually probably the thing on the log, right?
The thing on the log also tells you what the balance used to be.
No, it tells you what the balance is. If the system crashes and it's not on the log, you ain't got it.
Exactly. The log is the truth. It is the absolute truth. But the log is not on your computer. It's somewhere in the bowels of the bank. You know.
This is all irrelevant to the question that you're talking about a whole different problem than Bob was talking about. So, and I mean, you can talk about it, but it's a different problem.
Databases are sometimes models and sometimes not.
It's a confusion of the word model.
No, I've taught logic. I know what a logical model is.
Logical sense, as a mathematical structure. A model is a mathematical structure consisting of relations, et cetera, et cetera.
Yeah, I know what a model is.
True of some formulas. That's what I always learned a model was. If you wasn't true, it was just a structure.
But it is this thing that is described by the axioms.
No, but the structure, you're saying the structure is a model of an abstraction of the real world.
But the database is the
That's a different concept.
But if the database is the
We're
truth,
wasting our time here.
okay, no problem. Anyway, it's past my bedtime already, so
I would say
Where are you, Roy?
I'm in Paris.
Okay, great.
It's 11:30 at night here.
Uh-huh. Well,
I would say something about how people in natural language handle negation. It was very problematic because when you do embeddings into vectors of sentences, if you put a little not there or not, it kind of doesn't change the proximity of those two vectors in the n-dimensional space. So there is a lot of work in natural language processing about rewriting negative statements by using synonyms, for instance, or antonyms, basically, to actually state positively what they want to state. And by doing that, actually, the distance between vectors becomes reasonable and the embeddings work. So I have seen also in logic programming things like constructive negation and variants of replacing negation as failure with limited, at least, but always possible positive equivalence. And as a programmer, I almost never use negation in Prolog. I know that it doesn't bind variables, so why would I use that? It doesn't give you answers. It just eliminates answers as a constraint. So I'm not particularly interested in using it, and I live happily without.
Not interested in eliminating implicit or
I have to
wrong.
leave. Sorry, I'm going to have to leave, and I want to especially thank Annie and David for organizing this. It's been a great meeting, and I apologize if I've been out of step. So thank you very much,
Bob, for all your contributions.
yeah. Thank you, Bob.
Thank you for coming, and thanks, Peter.
Yeah, I think I'm going to have to back out too. I'm a grandparent, and I have a standing Sunday dinner meeting, Zoom with my grandchildren. So no
Wow.
offense to any of you guys, but
But I have to go too. I have to go to sleep because I have to work tomorrow. So
Oh yes, Monday. Amazing. This is a Sunday.
Thanks
Oh.
again, everyone.
Yeah.
okay,
Yeah,
thank
bye.
you everyone for a great workshop.
Thanks
It was
for
really good.
organizing.
Annie,
Bye-bye, everybody.
Okay.
Thank you.
bye, Costis.
Bye-bye, Peter. Bye. Bye, Annie.
Bye, everyone.
Good to see all of you.
Bye-bye.
Bye, everyone.
So Annie, what are you working on now?
Oh, hi, Carl. You're still there. No, where I think that this whole room is on live streaming. So, right. I mean, actually, they were talking about these closed word assumptions, so on. But that's one of the things we talked a little bit. You saw at the OLFCS, right? The same logic, I mean, the same language, but you have a completely different meaning depending on what you what you say as your declaration, what's your underlying assumptions.
Mhm. Very
But
good.
anyway, I'm so glad you mentioned about these things about concurrency and so on. And that's absolutely, I think it's really, and of course updates. And the only thing I think you're a little controversial, or at least not the one that some people agree, and even I feel that was about higher order logic, right? I thought that was really, I mean, sure, it's a great concept, and for some maybe a little use, but you know, hopefully, you know, my kids, I mean, my students have trouble understanding first order logic, so higher order logic will be too hard.
Right, the people doing higher order logic have to make it, you know, even more intuitive than first order logic, or they don't have a chance. I mean, that's clearly where they have to go if they're going to have success. But the thing is that unless you, as Dedekind realized in 1888, unless you use higher order logic, you don't know what you're talking about. With higher order logic, Dedekind was the first one. His axioms for the natural numbers specified up to isomorphism of just one model. So then we knew what the integers were. Before that, we did not. They're precisely Dedekind precisely specified that, but he had to use higher order logic to do that. There's no other way. You can't do it in first order logic.
Well, so actually, while people are talking, even from the very beginning, since the discussion, you know, since actually it was really creative, Lamport has this idea, so we'll have discussion even before any talk. I start to feel what we need is probably something we did the last time, was some kind of a challenge problem, right? So here is a practical problem people need to express, and people have different positions and say, how do you express it? Because talking in abstract.
Paxos is a very narrow problem, okay? And people do concurrent systems. Most of the work in concurrent systems is done without Paxos for sure. So if you want to have a problem, you need to have, I think it needs to be more general, a more general kind of thing. Not otherwise you just get narrow specialists in a certain branch of a particular branch of distributed systems who want to do this particular thing with absolute consistency, and you'll lose your audience. It'll be too narrow.
Okay, well, I really think a lot of these arguments are really, I mean, I think for people like you and many others, they've been thinking all their life. So they have really good insight and make these general arguments. And a lot of them, I think, I mean, I'm sure I heard some of these years ago, right? Higher order logic, higher order function.
Yes.
Anyway, higher function is more trivial, but anyway, are things I feel, you know, I sort of you take the words until you finally realize yourself.
That's right.
So maybe the best thing for people like me or newer people didn't know the older things, or the not necessarily older, better things, is to have an example.
Oh, I think I agree with your idea of an example. I just think Paxos itself is too narrow.
Well, Paxos is just one particular algorithm. But it is one of the most important one, right? Especially, you know, for elections, and the whole distributed system needs to make agreement.
Well, I mean, that's controversial, actually.
Oh,
But
really?
never mind.
Why?
Because it's very slow and it has a reboot problem. There's a problem with Paxos. It has this reboot. But what do you do when Paxos fails, right? And so we have these various patches that systems use where they have to reboot when Paxos fails. So
Yeah, it doesn't.
so people are moving on to other things now.
Well, things do fail, and Paxos handles a lot of those.
Right, but it doesn't handle all of them. So now
Right.
what?
So in the worst case, you restart the system. But
But, you know, but when you have to, people, I mean, at Amazon, when you have to reboot the system once a day, they start getting very worried because they know as the load grows, soon they're going to be rebooting the system every 2 hours.
which algorithm does Amazon use?
What?
Which algorithm does Amazon use? I mean, no, this doesn't happen that often, right? To reboot every day. I mean, it's probably months or something.
Well, unfortunately not. Go talk to the guys at Amazon.
Really? Which algorithm do they use?
They now roll their own. They have their own ways of doing it too. That has more robustness built into it. So it's not as fragile as Paxos.
Well, Paxos, I'm not sure it's like one so specific algorithm, right? It has some aspects, and whatever new ones they build, it will have the same kind of aspects. Of course, Paxos was first written using more about the correctness arguments or whatever logic specification versus all the algorithm details. So other people filling out
The
the
other thing that
details.
happened at Amazon is they couldn't stand the overhead of all this voting. That was just too much for them. And leadership election, it was just too much for them. So they had to find a faster solution.
Interesting. But what is another solution if it's not a leader election?
Oh, it's proprietary to Amazon, unfortunately.
Yeah, but there's no, I mean, I don't know if we discussed this, probably not when we met. I had a colleague who was retiring. This is many years ago from Stony Brook. And this guy, by the way, I thought he looks younger than me. 2014, actually, he organized the last meeting at Ottawa. So I said, what are you going to work on? He said, working on these elections. This is in Canada. Said, what do? We think, I think, whatever, sound like he has, not just him. The right way for society to run is not to have an election, find one, I guess in Canada, I don't know what is it, but anyway, one party or something to lead. You vote on who's that person make all the decisions or whatever that whole government is. You vote on issues.
Ah, interesting.
So I thought, wow, that was interesting. How come never in my life I thought about it?
Well, okay. Well, we do that in California, and it means that if you have enough money, you can buy an election on an issue. And Uber and Lyft just did that.
Oh, really?
Yep.
Oh, I didn't know that.
Yeah.
But I got excited in blockchain. I wasn't excited at all. I knew those for 10 years at least. But I actually, exactly when it came out, right? 2018. But anyway, I thought I finally, actually, as part of understanding of Paxos, I didn't understand for many years. You sure understood what's the words, we didn't understand intrinsic. What Paxos does compared to, for example, Bitcoin algorithms and lots of these blockchain algorithms when it first came out, is you so-called elect a leader. But why do you do that? It's because so that this leader make decisions, so you do not have to vote on each issue. That's much more efficient. The only reason if people think the leader election overhead was too much was because they didn't implement it right in all details, right? Had it done too often, so have these new ruling. That's Google did this, right? They call it Paxos. It has this, sort of called depend on, anyway, you can just basically call it a failure detector. That's the standard name. So this way you do not, if the leader is alive, then you do not have to really elect the leader, and that's very efficient. So, there's so much detail, right? This particular Paxos description or in anybody's description, most of them, they do not say all of that. Or for the ones who did have to say all that detail, there's so much detail, it wasn't formal or precise. Maybe it's English. So
what Amazon has done is they have a scheme of they've given up on absolute consistency, right? They have a scheme for doing repairs, and they know that in order to get higher performance, they know that they know that they're going to screw up a certain percentage of the time. And if you just keep that percentage small enough and you have repair procedures, right, then they think it's better to be responsive, particularly around Christmas time when they're under enormous load.
I see. I
So
see.
they accept a certain number of failures. But they price it in. Same thing for the credit card companies. In other words, they price in a certain percentage of fraudulent transactions. That's priced into it.
I see. Interesting. And I mean, we teach these Amazon's Dynamo database or whatever they're, you know, of course, there when they use that, which is for the shopping carts, not the critical transactions. Your shopping cart, if you lose it, it's okay.
No, it's not okay. Not if you lose a lot of them. That's not
But
okay.
the ones when you really sure you check out and know that it cannot be wrong, right? So, I mean, actually, they at least their original papers, right? They said that that's the trade-off. That you know, this particular one is only used for this, not that. But
Yeah, right.
definitely, most customers want to check out, and that has to be correct. But definitely, you know, this distributed system is just not 100%. It can not even all solved by computer. By the way, I had this friend. He's, I think, the main guy. I think really doing all these transactions for IBM, right? I remember he was telling me all the difficulty. I won't tell you all the detail, but finally, I say, because that's my problem for 20 years. I didn't want to study distributed system. I thought I just couldn't think what's going to happen. I cannot make sure it's correct. But basically, after all the argument, he said, what you do is big banks around the globe, it's like this. You pick up the phone.
Right. So I just ordered a computer, right? And we did a change. Okay, so they canceled the previous order. So I'd had this order. And then they shipped the cancel order anyway, all the way across the country, even though it was canceled.
I hope they don't charge you. That's all you need.
So I had to refuse delivery, right? Lucky them.
Interesting. Oh my God, 5:40. Okay, I have to go and cook.
I gotta go too. Yeah, right.
Yeah, but thank you for coming and all your
For running
comments.
this.
You send all these nice links. If I lost any, I will ask you.
Oh yeah. So anyway, if you just go to my blog, all the links are on my blog. You just go to Blogspot, the Google blog, Professor Carl Hewitt, and you can get them all.
Okay. Okay, great. Thank you.
You're welcome.
Yeah, have the last and few hours for the weekend.
Yeah, there we go. Okay. Bye-bye for now.
Okay, bye now. Oh, hi, Matthew. Now it's just you and me. Thank you for all your work. Boy, that was long. I think next time we'll definitely going to run 2 days. Oh, you're muted. I can't hear you. Gosh, anyway, I want to get my drink, sort of not beer, but I think everybody would need that, right? Oh, do I hear you? I don't hear anything from you. No, I don't hear you. Right. Your public microphone is a different connect. Different part. Oh, now I hear it. Okay, great. Oh, so it's good you're here. Actually, I didn't reply to your email about the compiler.
Oh yeah.
But when we meet tomorrow, I figure you'll have several weeks now. You in a few days is okay. Actually, I have another big deadline tonight. I hope I can finish.
That's okay. Yeah.
But tomorrow I will look at like yours. Is that okay?
Yeah, that's fine. Yeah.
Yeah. Okay. But those are exciting things to discuss too. And maybe I should give you some quiz. What did you learn for tomorrow? There are a few times I thought about, oh, this is for Matthew, but we can talk about that too. Okay. All right. Thank you so much. And
That's good. And I've been recording the whole time, so I can do whatever with the recording.
Yeah. Okay. All right. And I guess. Okay. So bye now.